Greetings to everyone and a warm welcome to the Emerson booth at Hannover Messe 2024. And in today's conversation, we're going to delve into the increasing use of hybrid linear motion technology in automation systems, which involves a combination of electric and pneumatic systems. And we're going to explore how original equipment manufacturers, or OEMs as we call them, can select the most efficient motion control system to enhance their system's productivity and, of course, its overall sustainability. And so to do that, I am delighted to be joined by Gordon Muir, who is Vice President of Acquisitions and Business Development. And on my right is Reinhard Baumfalk, Vice President of Engineering Factory Automation. And you're both going to be offering some insights on this topic. Great to see you again, Gordon, and thank you very much for joining us.
Glad to be here, thank you.
Now to kick off our discussion, I think it's really important that we first define the technology that we're talking about, because nowadays, of course, as we spoke about, Gordon, OEMs have so many options to, when it comes to integrating motion control into their production systems. So how do we define and distinguish pneumatic linear motion and electric linear motion, and of course, which one is one better than the other?
I'd hate to place a bet on which one is better than the other. There are lots of options for both types of technologies.
And we still need both, right?
We still need both.
I understand
very much so need both. If we start with the pneumatics, so it's essentially moving or utilizing compressed air to move a mechanism. Typically, it's going to be a cylinder with an internal piston. They're reliable, they're robust. They've been in the industry and proven for many years. They are utilized heavily within vertical and handling. Indeed. Would be the two. If we're looking at electric linear, you're going to have an electric actuator. You're going to need a controller, internal sensors, and a servo motor too. But it in turn has a higher degree of capabilities with it. You've got speed one. Reinhardt's going to go into that later on. Relative forces, controls of forces, and then a higher profile of velocities within that tool set.
So you're dealing with a lot more speed there, if I'm understanding that correctly.
Higher speed. The pros and cons, and we'll get into the discussions later on, but those are the two technologies as they're defined.
Okay, so Rainer, then I'll just come over to you. How does Emerson go about defining the hybrid linear motion system?
So let's have again a look at the advantages both technologies bring in, where we talk about for the pneumatics world, then about easy to maintain and a very robust technology, and for the electrical actuators about speedy, intelligent, and also very precise technologies. OEMs had to make a choice in the past. It was an either-or decision they had to make, and the hybrid design gives the huge advantages to combine then the features, the benefits of both technologies in one product to come up with a more efficient, from a technology perspective, but also from a business perspective, more efficient solution.
Okay, so it's clear there's a whole range of linear motion technologies to choose from, and OEMs obviously have a lot of decision making to do. Gordon, in making these kinds of technology choices, what are some of the key drivers and also the challenges that they face in terms of keeping their automation systems competitive?
I think common ones across a lot of the segments industries is certainly energy consumption. It's kind of first and foremost on many people's minds.
Major topic.
Major topic. There's the cost reduction.
Okay.
Always been an item, of course, and then sustainability, which is visible across this entire show, of course, right now. So those come into the machine designer's mind when they're looking at their linear motion equipment. Certainly, with the advent of the digital transformation that we have across all industries, there is a multitude of intelligent devices, sensors spread across the entire factory floor that is bringing real-time data to critical parameters that are coming back to controllers, is going into analytical software that's being turned into actionable data that they can actively implement there and then to improve their operations. Customers are also looking for flexibility within their systems, so there's a modularity aspect to that they have within their designs. They're also looking to make best use of their footprint. So do more with less space is another criteria. So there's a lot on their plate. Those would be the top three that we hear from.
It's incredibly complex, really, and given the challenges and the market drivers that you've mentioned, obviously energy costs being one of the major ones, it seems as though selecting the actual right motion control system is going to be critical to reaching competitive goals. So perhaps it's helpful at this point to just simply break it down, and let's look at the key advantages and also the limitations of pneumatic, electric, and then the whole hybrid system altogether. So first of all, let's discuss pneumatics. Where are the advantages, and where does that stop, and do we have to,
It's been a recognized technology for decades, of course. It's been leaned on.
That's right, it's the old system.
It's the older system, still robust, still reliable, still capable. But are
there OEMs who are reluctant to leave it behind?
More a case of proof points. And I think the move toward our discussion here today, the hybrid aspect of it, there's many industries, I think automotive is still highly dependent and utilizes the benefits of pneumatic. You go to the other end of the scale with semiconductor, I'd say the pendulum has swung the other way. But in general, there's a higher growth rate within the electric linear motion, ELM, keep saying, than there is within
I like
pneumatics.
those short forms too.
There's, first and foremost, the initial purchase for pneumatics is cost effective.
Okay.
The capital expenditure that's required to install that system is also lower than the electric linear motion version. It is you expand, you contract. There's 2 points within it. We do have some technologies now within our differentiated pressure control systems, which allows a higher degree of complexity within the pressure profiles. That's good, a good capability that pneumatics didn't have before. There are some force and some speed limitations with pneumatics. I'm sure Ryan Hart's going to talk about the benefits on the ELM side of things. I would recommend, even outside of just that pneumatic actuator, to consider the impact of your larger compressed gas system.
Okay.
So we have gas monitoring solutions right now, which are being recognized within the industry and the field of the leakage rate is substantial across the entire system. And also, as you energize that pneumatic actuator, you do lose power. So you're constantly pressurizing it. So we do recommend, if pneumatics is heavy within existing install, to make sure that you've got a monitoring system in place.
Okay, so a good monitoring system in place, but there is also the possibility of the electric linear motion system. And Reinhard, perhaps you can just outline for us what the major advantages are that OEMs can appreciate when making a transition as well.
Absolutely. Beside the advantages we heard about the still young technology, pneumatic one, the electrical ones for sure have some distinct advantages. When we talk about the speed, when we talk about endpoint accuracy, when it's about precise positioning in the industry, there the electrical or linear motion systems have a clear advantage in.
And this is where things are getting, when we talk about digital transformation, this is what's being adopted, right?
Absolutely. So besides just the nature of the energy we discuss here, so the electrical one, which is easily and very precisely controllable, we talk also about digital aspects when it comes to control of the motion, when it comes to the digital aspects in how to apply an algorithm, a process control then to the system. When we have a look at the Emerson portfolio, we find there are some nice examples for electrical linear motion tools like the SPR actuators, where then also the versatility of the whole portfolio comes in, where we have then ball, lead or screw, or ball, lead or screw rollers. hours than in, sorry.
right.
See.
It's a lot of terms that are hard to get
many terms,
your tongue around.
and explains or makes very clear how versatile their portfolio is, where you have all these advantages in, where you can have a perfect tool for a precise automation application. Absolutely.
Okay, so that's interesting, but it's funny because when we spoke about this before, I remember, Gordon, you said that the pneumatic and linear used to be two completely different worlds. I mean, they didn't interchange at all. So machine builders have often had to, as you mentioned, choose the one over the other, make compromises. How can this hybrid motion control system then actually eliminate the need to be making compromises of that nature?
I think, and something we mentioned earlier on too, was that with the digital age coming in, with the digital transformation, power is required to these tools anyway. So apart from having just a compressed gas system in this, within the factory, every machine is now powered. HMI, SCADA systems. So the opportunity is there that you have power, you can use electric linear, but within that tool, within that system, that machine, you can optimize it by taking the best of both worlds within it. So you could have a gantry or a Cartesian system where you're utilizing the electric linear motion for the horizontal movements. You could have the vertical with a pneumatic point to point, and then a method for handling, for gripping. That could be a pneumatic piece of equipment itself.
Okay, so with all of these considerations, then how difficult is it to choose the right one?
It requires an in-depth analysis of the application itself. So what is the job to be done here? So when we talk about a box to be moved then on a conveyor or off a conveyor, the solution is the answer is quite a simple one, because that's a clear pneumatic task. It's already quite different when you talk about food and beverage process, so creating, blowing a bottle, filling a bottle, capping, packaging the bottles. Here we have a very complex setup where both technologies have their strengths and can be utilized in a hybrid setup, where you have then both pneumatic and electrical linear motions next to each other.
Okay.
If you go more in detail, an OEM should go through a number of key questions he has to answer first, just to bring in another parameter, like the topic sustainability. So here, customers should carefully analyze what are his energy target or his energy efficiency targets, and to understand and analyze which of the two technologies give a better efficiency here. But at the same time, we also talk about commercial aspects, like the CapEx intensity. As Gordon mentioned earlier, we talk about two different intense investments. So while the electrical units investments much higher, the pneumatics tools are a better investment if that is a critical criteria.
Okay, so
and just to mention another one, sorry,
it's
when we talk about connectivity and digitalization, for sure the electrical ones still have an advantage in giving back more data about what is going on in the process when it comes to positioning of products, when it comes to the monitoring of a process, where you get many more insights from an electrical device, a linear motion device, in comparison to a pneumatic one.
A lot more sort of live data flowing in there.
I think the aspect, and I know we're going to go into some examples.
Into some concrete examples.
But one point you'd made there too was the initial cost of pneumatics and initial capex for installation. When companies are going to go into taking all the advantages of the insights they can get from that data lake and be localized active control to improve real time their processes, the overall cost when they look at ELM over its life, they recognize is generally a better investment for them, relative to the insights they get for efficiencies, productivity, improving one line to the next as they garner that information. They look at that entire insight that they gain in ELM, hence the growth rate. The electric linear is faster than that for pneumatics, just with the overall life, the improvements, the OEE.
And that's really allowing you to sort of project into the future much better, isn't it? Yeah.
Repeatability, accurate yields.
Exactly. Concrete examples
Yeah.
of where Emerson has actually helped a
That's perfect.
customer apply this.
One was relative to tire. We're involved in tire movement and logistics and testing for some large companies around the planet. They were in pneumatics before. The repeatability of forces, speeds, they moved over to ELM, and they garnered the insights on one of their lines, optimized it, improved it, and then they applied that down multiple manufacturing lines to their benefit.
So
very quick.
Turning a motion then even into a sensing device by applying then the force, measuring then the process feedback, which is then a huge advantages for the OEM.
Yep.
So Emerson obviously has developed this comprehensive approach, helping OEMs, make more intelligent choices about which linear motion technology they're going to use. How would you, Gordon, summarize the benefits of using the hybrid system?
Yeah.
And how should OEMs actually get started when they decide that they want to make this very big step?
I think the good news is we have a capable, sizable portfolio, both in pneumatics and within electric linear motion. And then we have, with Emerson's expertise of automation, the applications engineering, as well as what we have within our HMI, our SCADA, our analytics. We're here as a partner to help first and foremost. A recommendation for how OEM starts is start small. Take a machine that you're looking to upgrade, or you've got a new application, and diligently go through the critical aspects that you expect to gain from this equipment without limit. And then talk to an expert such as Emerson. We'll help you get off the ground. Utilize that small insights over X period of time, glean the data to improve upon it, and then scale up. Would be the recommendation.
So it's really a piece by piece, step by step, and always evaluating and evaluating. Have you got anything
Following
to add?
the floor to cloud approach, so starting, as you mentioned, with pieces on the floor, so adding linear motions, either electrical or pneumatics, and also pneumatic devices nowadays provide data, so feeding or filling the data lake with process data, and combining that then with the other data analytical tools on the higher levels. This provides then the benefit to customers, plus that it allows to grow further into such a scenario and architecture.
Yeah. It comes directly into the floor to cloud strategy that we have.
Exactly, which we're talking about all this week at the Hannover Messe, and tomorrow, and continuing into the future. I want to thank both of you, Gordon and Reinhard, for unpacking all of this incredibly detailed information for us, showing Emerson's sort of comprehensive approach to these linear motion technology questions. Thanks very much for taking the time, and enjoy the rest of this year's Messe. It was great to see you here.
Again.
Both of you.
My pleasure.
Absolutely.
Thanks so much.
Thanks so much. To our viewers out there, thanks for your interest and your attention. And if you still have questions or wish to learn more about what we've spoken about here today, then just feel free to go to emerson.com and reach out to the many Emerson experts who will be more than happy to advise you on how to optimize your linear motion technology. That is all for now, so until we meet again, all the best and bye-bye.